A magnitude 5.6 earthquake shook southern Turkey on Monday. 3 weeks after a catastrophic tremor devastated the region, causing some already damaged buildings to collapse and killing at least one person, the country's disaster management agency, AFAD, said. Another 69 people were injured as a result of the earthquake, which was centered in the town of Yeşiliyurt in Malatya province, AFAD's chief Yunus Sezer told reporters. More than 24 buildings collapsed. Yeşiliyurt's mayor, Mehmet Siner, told Haberturk television that a father and daughter were trapped beneath the rubble of a 4-story building in the town. The pair had entered the damaged building to collect belongings. Elsewhere in Malatya, search and rescue teams were sifting through the rubble of 2 damaged buildings that toppled on top of some parked cars, Haberturk reported. Malatya was among 11 Turkish provinces hit by the magnitude 7.8 earthquake that devastated parts of southern Turkey and northern Syria on February 6. That quake led to more than 48,000 deaths in both countries, as well as the collapse or serious damage of 173,000 buildings in Turkey. AFAD's chief urged people not to enter damaged buildings, saying strong aftershocks continue to pose a risk. Close to 10,000 aftershocks have hit the region affected by the quake since February 6. The East Anatolian also accumulates energy at a slower rate than the California and North Anatolian faults. Dr. Stein described the East Anatolian as a second-string fault that had produced an earthquake almost as powerful as any expected on the much bigger San Andreas. That raises the issue of whether a California quake of similar strength might someday occur not on the San Andreas but on a secondary fault. While both past California earthquakes have been studied extensively, modern technology is allowing the Turkish quakes to be analyzed in elaborate detail, practically in real time, using ground-based seismic sensors, satellite-borne radar and other instruments. All large earthquakes are followed over days, months and even years by aftershocks, which often number in the thousands. These occur because the movement in the first quake can increase stresses along nearby fault sections beyond their breaking point. On February 20, 2 weeks after the first Turkish quake, a 6.3 magnitude aftershock struck at the southwestern end of the earthquake zone, killing at least 8 people and further traumatizing residents. The aftershock, which released less than 1% of the energy of the 7.8 quake, was within the range of aftershocks that would be expected, said Debbie Kilb, a researcher at the Scripps Institution of Oceanography who studies aftershocks. But the 7.5 aftershock that occurred soon after the first quake was unusual, Dr. Kilb said. Whatever the main shock magnitude is, you should expect the largest aftershock to be about 1 magnitude unit smaller, she said. So for a 7.8 earthquake, we would expect a 6.8 magnitude. At 7.5, the aftershock was more than 10 times stronger than the largest expected one. The reason for such a powerful aftershock has much to do with where it was located, on a separate fault from the first one. And scientists will likely be able to apply what they learn about that aftershock to the San Andreas. The East and North Anatolian and the San Andreas are all transform faults, products of the stresses that build at the boundary where one of the Earth's large crustal plates slowly moves past another. But in each case, rather than a single fault, they are actually fault zones, riddled with scores of shorter faults oriented in many different directions. That's what happened in the 7.5 aftershock in Turkey. Dr. Stein, who with colleagues has analyzed the changes caused by the first quake, said that it altered stresses on a secondary fault, the Surgut, that is estimated to be about 200 miles long and runs at an angle to the East Anatolian.